Hello, everyone. Welcome to my talk. I'm going to briefly talk about data pipelining in general, and obviously focusing on real-time and batch-oriented pipeline development, what things to consider and what not. So let's just jump right in. Real quick, though, before we start, just wanted to introduce myself. My name is Siddharth Jain. I have over 20 years of experience in data engineering and integration. I have experience in building data pipelines, both real-time and batch-oriented, hence this topic. And also built a lot of data platforms from scratch, either on-prem or on the cloud. Currently, I'm leading the data engineering space within Wayfair supply chain tech organization. So like I said, the main agenda of this discussion is to get an understanding of the different approaches to data pipelining, what's happening in today's modern data engineering environment, look at the pros and cons of each approach, form some basis in terms of guidelines, what things we should be considering when deciding on what pipeline approach we want to take. And obviously, this talk is by no means prescriptive. So it's just a channel or an avenue to share, my experiences and learn from what's happening in the industry. So let's take a look at what real-time and batch pipelines are. Real-time streaming pipelines is referred to as continuous data ingestion, processing of data in real time, and providing real-time analysis to end users. There is practically no delay in making the data available to our end users, except for the time it takes to process the data. The system and services that we use to build real-time pipelines are very specific and typically tailored for real-time processing. Services and tools that enable real-time processing have been getting more and more mature and are being leveraged more and more over the last few years. And it exposes a lot of use cases that were not possible till a few years back. Batch pipelines, on the other hand, run on a cadence, processing data every few hours or by day or by week, depending on your needs. It's a traditional way of building and executing data pipelines. And there are a bunch of tools, products available out there in the market, and a lot of them are very mature in the space. So let's look at a little bit more on real-time data pipelines. So what is real-time data pipelines? They are typically real-time pipelines are a paradigm shift to traditional data pipeline development. It provides processing which are super beneficial and addresses a lot of unique use cases. It's ideal for instances where data needs to be ingested and exposed almost instantaneously, like I said before. Typically, it's used to populate data lakes or data warehouses and also assist in event-driven applications. It requires special considerations, right from how we want to set up the ingestion to perform data processing tasks like validations, data augmentation / curation of the data, and persistence of the data in different data stores. Also, you need to do a little bit of more of orchestration and setup to have that data refreshed on dashboards in real time as well. So there are a bunch of tools that are available, especially now, being on the cloud. If you're on GCP, you have a combination of PubSub and Dataflow and BigQuery to do your end-to-end real-time data pipeline development. Similarly, for AWS, you have a combination of Amazon Kinesis data streams along with SQS or Azure AWS Kafka. Also, I have a little less experience with Azure, but I think Azure Databricks is something similar to what you would want to use when you're building real-time pipelines. Specific use cases for real-time pipelines are fraud detection, sub-marketing triggers, dynamic pricing, are all very strong use cases for real-time data and being used, as I said before, more and more in the industry. For the batch data pipeline, it's more of a structured and automated system designed to process large volumes of data on a scheduled basis, or is basically in batches, allowing data to be processed at a point where system is low in demand, thus allowing for maximum use of system resources. Once the batch processing system is in place, you pretty much have a very hands-offish approach to managing it. You don't need to check in or adjust anything. Pretty much it kind of like just self-drives for most part. You can also build a lot of like in-depth monitoring and alerting capabilities as well, which basically ensures that your pipelines are running. If there are failures, you get alerted. And then the biggest advantage of batch pipelines are that you get time to kind of like look at issues that arise and then fix those issues. Also, one of the other advantages of batch applications is that it supports dynamic provisioning of resources. What that means is, you can always scale up or scale down depending on the needs, right? So for example, if you have for example, now, right around the corner, we have the Cyber 5 / any of these big events coming up, right? Where you need to process huge amounts of data. So you can scale up your infrastructure to kind of run more, have more processing for your jobs, for example, and then you can always scale down. Even on a normal day-to-day basis, you can, when your jobs are not running or when they're not scheduled to run, you can do a lot of orchestration around spinning down your resources to very minimal, and then spin it back up when your time to run your jobs come up. So we do this very effectively at Wayfair as well. This also helps in managing our resources effectively and also taming our costs. It is a more and more mature of the approaches, but again, there's no argument on which is more mature or not, but it's just easy to onboard, easy to pick up, easy to learn, easy to leverage for most part, as compared to real-time development. What's also picking up a lot of interest, and a lot of people are ending up doing, is micro batching. So it's another approach that is taking a lot of prominence. It kind of merges the best of the two worlds, right? So you have micro batches which you can schedule and run every 5 minutes, for example. So it's getting as close to real time, as opposed to batch, which you would typically schedule once an hour, once a day, or whatever. And the logic to implement batching for micro batch processing is not very different as compared to batch processing. So you can basically, depending on what you're after, like you can go back and say, hey, go and give me all the unprocessed data from the last 5 minutes or 10 minutes or whatever it is. Or let me go back and see how many files are getting generated in my bucket, and then I can just process those, ever so often, right? Depending on the frequency that you've set up. So implementing micro batching is quicker as compared to real-time pipelining. It's basically kind of like an extension or something to a batch processing framework. And so it really takes minimal effort to get going with it. You also don't need to invest too much of technology onboard any new stack for performing micro batching. Also, by splitting up the data into smaller batches, you can reduce your workloads on the resources, leading to improved performance and low latency. You have less data to process, you do it faster and quicker, and things like that. Because the data is processed in smaller sets, it can be completed quickly, efficiently, and as it was done using a single set of data. This also allows you to process larger volume of information faster than it was before. So the biggest thing I wanted to drive here in this conversation is, just some consideration that we need to give when evaluating whether you want to go with batch or real time, or let's put it that way, where when you don't want to, or things that you need to consider in general before you start onboarding and into using real-time pipelining efforts. So, all three approaches are, as I said, are being used across various organizations in different shapes and forms. So, in fact, most companies are even investing into the Lambda or Kappa architecture, where they have, a a part of the that platform doing batch processing, and another part doing real-time processing of data. So there is no, and obviously there's no denying that real-time pipelining is needed or is needed. And obviously, as we said, like, there are a lot of use cases for that. But we should take a hard look to see why we need to invest in why we need to invest in, and what are we really getting out of it. I think we need to have a balance for that. As you know, if you've gone through that journey, real-time applications requires a different mindset. You need to go through some learning before you even start like building out these pipelines, as compared to batch. So usually the tools and frameworks that are there, or that make these real-time pipelines available, are quite different, and they need to go through like some sort of training, look at documentation, videos, and things like that. So that's one cost associated with real-time data pipeline development. Also, there are some design considerations also that you need to make. So for example, these pipelines run in a continuous fashion, right? And as a result, there is some complexity involved with it. It's difficult, I would say, to have proper alerting and notification process in place for in case there are issues that come up. Since typically the real-time applications are critical in nature, with very little or no appetite for failures, it is very important to have redundancies built into the design. And also, if there are any failures that happen, you need to recover from it very quickly. And you also need to have a backfilling / reprocessing of data available. So that process needs to be very solid in case there are failures and you're losing records, or you're failing to process records in time, and you need to catch up eventually, right? So if you're building and to come to the third aspect of it, right? Cloud-based, cloud-native services, typically, something like a Google PubSub or SQS, and then AWS Lambda or Dataflow will they charge you for every message that was sent or received, or every operation that happened, every task that was executed. They charge you for that, and all these charges can snowball, depending on the volume of data. And trust me, the volume of data keeps increasing over a period of time. So these services charge by the size of the payload as well. So you want to make sure that your payload is also as small as possible. So for example, if you're doing event messaging, or if you're trying to process, some CSV data or some JSON data or something of that sort, right? You don't want to embed that within your pipeline or within your payload, for example. You can probably have a pointer to the file that's located either in your file system, file store, your bucket, if it's like AWS, GCS, or whatever, S3 bucket or GCS bucket, for example. So at least that way you can reduce the size of the messages that are coming through, and then accordingly get charged less, for example. So I mean, those initially are not evident as when you're doing your development and stuff, but then these will catch up, or these will snowball, as I said, eventually. So I'll give you a quick example for one of our use cases that we had at Wayfair. So we had a process that would basically log every step of the execution into a table, and we were doing that and then that data that we were logging was getting exposed on a front end to say this is the status of our jobs and stuff. So and it was kind of like a custom application that we built. And so every status that was we was logged, we basically what we did was every status was getting was we published every message as every status message was published as a message to Google PubSub. And then from there, we were invoking data flow to process that data, to process that record, and then persist that data into Google BigQuery. So Wayfair on a weekly basis, we have like 2 to 3 million jobs that run. And if you do the math, if you are logging every step of every process, every pipeline, for example, that we're talking about huge number of messages that get generated, processed, and logged. So obviously that cost kept on increasing over a period of time. And the number of jobs keep getting added. Nobody really goes back and like gets rid of jobs, right? So we had to literally at some point of time take a hard look at how we want to do this. We had to re-architect our solution a little bit. And in that way we would get our costs back in line to what is expected. So yeah, so these are some of the design considerations or cost considerations that you need to take into account for implementing a typical real-time pipeline. So yeah, so just to wrap up here, so the main goal of this discussion was to present the various approaches available to us in a very and how to be pragmatic in our adoption. At the end of the day, the choice of the approach will be based on the use case. That's simply put it that way. We should definitely take a hard look at what can really solve, what business problem we're trying to solve in the most effective way. We don't always have to run after every shiny new tech that gets released. I think the engineers are very, they want to obviously work with newer tools and technologies that are out there so that they can build some credibility within the firm and take on like doing some good work. But there's always other options that are there that can do the same job in a different way, in a very cost-effective way. So typically, you can have you'll have a better chance of success if you start off with a batch approach, for example. Do a lessons learned from it, mature the process, mature the end-to-end flow, and then we can always refactor into a micro batch or a real-time pipeline. But again, as I said, at Wayfair we have a hybrid approach to things. We have a lot of our pipelines that we have built, especially within supply chain tech, within our data engineering org, is a combination, right? Which is we're ingesting a lot of real-time event data coming out of our, let's say, our warehouse management system or our transportation system or some other like carrier-related information and things like that, right? So we want to get that information in real time. We bring it and land it through Kafka into our landing zone. From the landing zone, then we have micro batch applications that pick up, a bunch of records which are unprocessed records, and then process it through various stages and curate it, and then bring it into our curation data layer. And then eventually we take that data from a curation data layer into our analytical environment. So definitely real time has its place in your architecture, in your data platform. But again, the goal here was to kind of like bring up certain certain factors that you can take into account before you decide on what approach to take first. So that's pretty much what I had here. Any questions and all, I'm here to answer. Thank you.